At various political rallies, people are asked what type of ice cream is their favorite, but they could choose only one. The table shows the distribution of ice cream preference and political affiliation. Okay. A person is chosen at random. When I make the statement, a person is chosen at random, what is the sample size that is implicitly stated by the previous sentence? And the previous sentence is this one. What does this statement imply the sample size is? Yeah, and I hear somebody raising their hand, and it's a 1. That's right. A means singular. So all these questions are singular. Again, I cannot emphasize this the most. Make sure you kind of understand that this is singular. So now, really quick, what is the probability that this person is a Democrat that chose other as their favorite ice cream? So let's break this down. What is the probability? Okay. So now that. So we're about to describe what we want the probability of. This person, again, it's a person, great, is, and now here we go. This is going to signify that all we know is a person is chosen at random. And we want to know the probability that this person is what? A Democrat. Okay, we want him to be a Democrat. But we don't know if they're a Democrat. The question is, what's the probability that they're a Democrat? And now we have this word here that chose other as their favorite ice cream. So the favorite ice cream is other. The question becomes, what connects these two events? Democrat and other. Anybody have any idea? That's right, and. So notice we don't have to say and in order to say and. So, but we have to kind of break these sentences down so we understand, okay, what is the probability of is, and now we're about to describe what is it we want the probability of. That chose ice cream as their favorite, meaning they want to be Democrat, but they also chose ice cream. So the question is now Democrat and other. Here's another way that we can, so let me write this out now. So Democrat and other, that means that I'm sampling from all 10,000. My population is all 10,000, and this has given me no indication that I'm choosing something else. So this is choosing from all 10,000 participants. Democrat and other is the 1568 right here. So you see this is about 1568 is my decimal. Okay. I'm going to make a different statement here just so we can connect it. What if somebody said, so in English, brown shoe, we can connect these two events, brown shoe, to make it more palatable to the tongue. But in reality, when I read brown shoe, how would it look like using these conjunctions, these things that unite words or events? How would brown shoe be interpreted? Must the object be brown? Yes. Must the object be a shoe? Yes. So brown shoe is interpreted using these conjunctions as, that's right. So what I'm trying to point out is you have to transfer things that are written in plain English to sometimes these other statements. Okay. But that means you have to get in your mind understand like, okay, how are they thinking about the events? Okay. So just kind of another way. So notice there's no and here, but I had to understand that that thing was an and. Democrat that chose ice cream means, okay, this and that. There's two things here. All right. A person is chosen at random. What is the probability that this person chose vanilla and chocolate as their favorite ice cream? So notice what it is. What's the probability that this person chose what? Vanilla and chocolate as their favorite ice cream. What's the chance of that happening? What is it? That's right, 0. Because in this table, these people, all these are disjoint. They're mutually exclusive. You cannot choose two things. You cannot find yourself in two little spots. So this joint area unique. First part of the combo. So notice again, vanilla and chocolate, 0, because there's no way you can find yourself in both. Okay. If a person chose chocolate as their favorite ice cream, what is the probability that this person is Republican? So notice if a person chose this as a favorite ice cream, what kind of conjunction am I going to use here? And, or given. And what now, when it's and, the two events cannot have occurred yet. So this is the difference. In a given, one of the events is assumed to have happened, or that's all we're. I hate to say. I mean, books say this. It's assumed to have happened. I like it to more because I like physical things to be very physical. It just means that I'm no longer considering everybody. I'm only considering a particular group. Okay, so these two get confused a lot. And this is the thing you have to kind of think and read the sentence until it's clear that you can differentiate between the two. But if a person chose chocolate as a favorite ice cream, notice, are we to assume that they chose chocolate? Yeah, it is. If a person chose chocolate, that means, okay, assume that's true. Just forget about it. There's no longer. So then which conjunction should be used? And, or given? Yeah, Valerie's got it right. It's a given. So this means that we're assuming chocolate is already been described. That's all we're dealing with. So if a person chose chocolate as a favorite ice cream, what's the probability that the person is Republican? And now the question is, what is the probability? No, this person is Republican. That's all we care about. Notice, what is the probability this person is Republican, but with a little disclosure. So all we want now, the bottom is chocolate. That's all I care about, chocolate. And how many people are chocolate lovers in this group? I didn't hear you, but I'm going to assume it's you got it right. So it's a 51,116. So yeah, this is everybody here is just a chocolate mania. And that's all we're talking about now. Now that the Republican means that we're only talking about considering these 2,000 people. The only way that now you can have a Republican is if they're chocolate lover and Republican. So that gives you the 2,000 people. So I'll make one more little statement that I didn't earlier. This is known as conditional probability, meaning you're now going to throw in a clear condition with respect to everything that's happened. So again, this becomes the given right here. The given or the condition. Let's do a couple more here. How would you do D? What is it that we're after in D? Hopefully you wrote this. Oh, who cares about the chocolate? There's no condition pace here. There's only one event. So that means I'm to assume this person is coming from all 10,000. Is that 10,000 or 100,000? I can't tell. Yep, it's 10,000. So the only people that are chocolate out of 10,000 is the 51,116. In other words, notice before in this question, the chocolate was the given, that became my total. But in this question, all I care about is chocolate with no conditions, everybody in the population. So now that becomes the thing that I'm after out of the entire 10,000 or whatever it was. Sorry, I put an extra one in here. Look at question E. A person is chosen at random. What is the probability that this person is a Republican or a Democrat? So the one is probability Republican or Democrat. So again, notice no condition given, no condition. So I'm assuming coming from the entire 10,000. So what's the chance of being Republican? Sorry, yep, Republican, there were 4,200. How many were Democrat? 4,600. Are these two events, do they have anything in common? Or are they disjoint? So Alex says disjoint. They're right, they have nothing in common. You can only be one or the other, not both. So that's it. So here I don't have to subtract anything because there's nothing to subtract. They have nothing in common. I'm not double dipping. So that's going to be 8,800 over 10,000. Okay. And one last one here. And a person with other party affiliation is chosen at random. So notice they're just telling me that that's who they're chosen at random. So this is now a condition. A given. So I am to choose nothing else. So they belong to the other party. The question is, what's the probability that they chose other as their favorite asking? So what I'm after is other and ice cream. That means, again, I cannot look at the entire table. I can only look at other party. That's the only thing left for me to think about. This is the entire population now. It's just nothing but other party. So I look at other party, and there is 3,684. And of those, 420 chose the other ice cream. All right. So notice it's just a matter of reading between one statement and the other statement. Okay, which one is it? What am I doing? So this is more just reading comprehension, reading very carefully and making sure that I do understand what and or given is, and then making the correct connection. Okay. So let me stop here. Questions. So it looks like, yeah, I'm already seeing. Yes, go ahead, answer your question. I might have probably going too fast. Yes. That's right. Sorry, I was looking at the thing, but I wasn't looking at I just saw the other, but it's the other party affiliation. So it's the 1,200. Yep. Yes, I was reading your face and I realized I looked back down. I go, oh yeah. So waiting for somebody to ask the question. And you did. Thank you. Yeah, I mean, if you catch something, just say something. Just see something, say something. All right. All right, folks. Let's stop here because that's the end of this part.